Hello, and welcome to this demo of the cnMaestro X management system. This video will provide an overview of cnMaestro X and will cover its key features. Please note that I have listed the features covered in this demo and the time that they appear in the video so that you can fast forward to a particular feature if you wish to review it at a later date. cnMaestro X is an enterprise-class management system for Cambium Network's entire product line. cnMaestro X is available in a cloud-based version or an on-premises version delivered in an OVA file format. In a single pane of glass, you have visibility into the entire Cambium Network product line. cnMaestro X allows you to manage the complete lifecycle of Cambium devices. The interface is intuitive and easy to use, allowing for faster times to productivity. It also provides for easy onboarding of products with zero-touch and auto-provisioning. The system offers a robust set of troubleshooting tools, including remote CLI access into APs and switches, packet capture file capabilities, and a spectrum analyzer. cnMaestro X provides APIs and webhooks, offering integration into third-party applications such as Slack, Datadog, and many others. I'll start the demo with onboarding new products. Let's say the IT manager has ordered new APs or switches. Auto-provisioning in cnMaestro X allows the system to automatically configure and approve newly added devices. Custom configurations are based on the device IP address. When cnMaestro X sees a new device being onboarded, it looks at the device IP address, and if that IP address falls within a certain range, cnMaestro X will apply the appropriate auto-provisioning rules to that device. When a device is onboarded and detected by the auto-provisioning rule, the device will be placed in the configured managed account, network, and site. Also, the device gets placed in the appropriate AP group, where it will receive its configuration. cnMaestro X provides enhanced guest access portal capabilities, allowing you to provide custom guest access portals for your different networks. The guest access portals can be free access portals, or they can require payment for access to the Wi-Fi network, or they can be voucher-based access portals. The system supports a maximum of 500 different access portals and a maximum of 10,000 guest sessions. Creating a custom access portal and splash page is very easy in cnMaestro X. When creating a new access portal or editing an existing access portal, you will see 4 areas available to configure and manage the portal. The splash page allows you to create and customize the portal landing page. You can start off with any of our 4 templates and customize the page to your requirements. You will be able to import the company logo, a custom background, and apply your custom message. Okay, we've just created a guest access portal. Now let's assign a type of access to this portal. You will have flexibility in the type of portal you want to create. The access page allows you to create and configure free portals, paid gateway portals, and voucher-based portals. If you choose a paid gateway access portal, notice that you have several paid gateway services to choose from, including PayPal, iPay, and several others. You will only need to supply the token provided by your gateway vendor. After you have changed this portal to a paid gateway portal, you might want to change the text content of your splash page. After guests have started to use the portal, you can view client session information on the Sessions page. The Sessions page will display client information such as the MAC address, the wireless LAN it's connected to, the access point it's connected to, and how much more time is remaining on that client session. EPKS are unique passwords assigned by the administrator to each device connecting to the Wi-Fi network. cnMaestro allows you to create and manage up to 1,024 EPKS, which can then be exported into a CSV file format. Administrators can use enterprise pre-shared keys as another method of controlling access to the Wi-Fi network. In cnMaestro X, the administrator can choose between system-generated passwords with the password strength of easy, which is 8 characters, strong, which is 16 characters, or number, which would be up to 8 numbers. Using this method, he can generate EPKS individually, or he can create multiple EPKS in bulk. He can also assign a VLAN the device will be placed in when successfully connecting to the network using this EPKS. The system will generate the EPKS and you're ready to export them to a CSV file. Another option for the administrator is to import his custom list of users, passwords, and VLANs in a CSV file format. It's very easy to create the custom list in this CSV file by downloading the sample file, filling it out with names and passwords, and then importing it back into cnMaestro X. Now that we've configured the APs, a guest access portal, and EPKS, let's configure the switches. Switch groups are very much like AP groups in that they are the configuration golden template for Cambium devices, in this case cnMatrix switches. You can manage hundreds or thousands of switches very easily with cnMaestro switch groups. You will configure basic settings, network settings, and policy-based automation in a switch group. You will configure the switch group with contact information, admin and guest login credentials, time zones, DNS servers, VLANs, and configure policy-based automation. Policy-based automation allows you to manage your switch port configurations automatically. A PBA policy will identify devices that come onto the network, and if certain criteria are matched, the port will be configured automatically with a configuration you have put together. Policy-based automation is made of 3 components: rules, actions, and policies. Rules specify the identification criteria used in this policy. When selecting a type of identification criteria, you have several options. Devices will use a protocol, LLDP, to exchange identification information with other devices on the network. So when a device is plugged in, it starts sending this LLDP information, and the switch reads this information and will identify the device. In this case, we'll select LLDP any, meaning that we're looking for any LLDP information, and the device data that we'll be looking for will be XV2. Actions are steps taken after a device has been identified. This is where you configure the port template. You will set the switch port mode, add the VLANs and the native VLAN, and configure any of these other options, including the PoE priority, which will ensure this device does not lose power in the event the switch PoE gets oversubscribed. So we have a rule which profiles and identifies the device and puts it in a class. An action will configure the port after the device has been identified. Policies stitch together the rules and the actions. In this case, we're saying if we see an XV2, we're going to configure the port with the XV2 actions that we just configured. Now, with this policy in place, every time an XV2 access point is plugged into any one of the switch ports, that port will automatically be configured with these settings. And another powerful feature of PBA is that once a device has been disconnected from the switch port will automatically be reset back to its previous configuration. Now that the network, including access points and switches, has been configured, you will start to manage the network and monitor the performance of both network and client devices. cnMaestro X includes a client dashboard, an application page, and a performance page, giving you visibility into the client activity and the quality of experience, and is also great to troubleshoot client device issues. cnMaestro X collects and displays health and performance statistics on network and client devices. The contextual dashboard changes scope and will focus on the information for the level in the network you are reviewing. When you go to the Clients page and select a client, you are directed to the Client dashboard. Notice the other pages of client information, the Applications and Performance pages. The Client dashboard provides information on the client device, information on the AP it is connected to, the applications the client is using, bandwidth history, roaming history, and performance metrics such as RSSI, signal-to-noise ratios, and data throughput. On the client history chart, hover your mouse over any point in time to get uplink and downlink information. The Applications page has a pie chart representing how much of the total bandwidth each application is using. The chart on the right shows you when the application activity occurred. Click on a different application in the pie chart and notice how the chart on the right changes to reflect the times and usage for that application. The table at the bottom shows the details of the applications, including uplink and downlink bandwidth usage, a productivity index, and a risk index. The Performance page shows different performance metrics such as RSSI, signal-to-noise ratio, data rates, throughput, and application throughput. Hover your mouse over any part on any of the graphs to get the data for each of the graphs for that particular point in time. Click and drag your mouse over any time period in the chart, and the chart will zoom in to that time period. Notice how the other charts zoom in to correspond to the time period you just selected. So far, we've configured the APs and switches with AP groups and switch groups, and now client devices have been connecting and using the network. Let's say an end user calls into the help desk reporting poor Wi-Fi performance at around 11:30 to 12 o'clock last night. Well, cnMaestro X provides numerous tools and information to troubleshoot the client device. You would go to the Clients page and search for that device by MAC address or hostname, and then click on the hostname for the device. The Client dashboard shows us details about the client and the AP it is connected to. You can review the client device throughput history, RSSI levels, signal-to-noise ratios, and data rates for different points in time. You also have visibility into the client device roaming history. When you hover your mouse over the graphs, you get a snapshot of how the different performance metrics looked at that point in time. We can see that from 11:15 to 11:30, the RSSI level dropped from -48 to -71. This is not a good sign. In that same period, the signal-to-noise ratio dropped to 15. Again, not good. Data rates and throughput dropped at about the same time. And notice that all this started to happen right after the device roamed from one AP to another. In this case, it appears that right after the client device roamed from one AP to another, the RSSI level and signal-to-noise ratios dropped pretty dramatically, thus causing the drop in performance. This could have been caused by interference or possibly the client moving into an area that has a poor Wi-Fi signal. Now let's say that the help desk gets another call reporting poor network performance. This time, the engineer suspects that it might be a switch causing the issue. When you are drilling into a device to review performance and health statistics, the dashboard context changes to focus on only that device. The dashboard has details about the switch and individual switch ports. A red port indicates there is nothing connected to the port. A green port indicates a port with a connected device, and a green port with a little blue lightning bolt indicates that port is delivering PoE power to the connected device. You can hover your mouse over any of the switch ports to reveal a pop-up window with status and configuration of that port. In this case, an XV2-2 access point is connected to this port. Clicking on the port will change the dashboard context to reveal details about that port. Clicking on Actions will provide more configuration and troubleshooting options. Oftentimes, a device that is having issues only needs to be rebooted. Toggle the PoE on that port to reboot devices remotely. If the reboot does not solve the device issues, you may want to further investigate the switch port. Selecting port operations will bring up a switch troubleshooting page. By selecting the port, you will have access to several troubleshooting tools. If you run a diagnostic test on the cable, you're testing layer 1, the physical layer, the actual cable itself. If a fault is found, the system will indicate the distance in meters the fault is occurring on the cable. You can also enable and disable a port, enable and disable the PoE on a port, or just toggle the PoE power on a port. Let's say you're getting reports that an access point appears to be having issues. You want to review the switch port information, but do not know which port the access point is connected to. You can use the remote access into the switch CLI and run the switch OS command, show LLDP neighbor detail. This command will provide a list of the devices connected to the switch ports, including the connected device information. Make note of the device connected to local interface 9. This is the XV2 that is misbehaving on the network. You can locate the device in the network tree and click on it to access the device dashboard. This illustrates the power you have in the dashboard when troubleshooting devices. On the Tools page, you can take a snapshot of the device configuration, activity, connected devices, and RF environment by creating a tech support file. The file is pretty much everything you need to investigate and debug the issue. You can use the support file to debug the issue yourself, or you can open a support ticket with our engineers and send them the support file before they even ask for it. Also on this AP troubleshooting page, you have remote access into the CLI. You can run packet capture files on the Ethernet port, the wireless LAN, the VLAN, or the SSID. The file output format is in a PCAP file. The Wi-Fi analyzer will analyze the RF environment around an access point. The access point will scan the RF environment in the 2.4 GHz and the 5 GHz bands. Results of the scan are shown in the graph at the top of the page and a table at the bottom of the page showing the SSIDs, channels, and signal-to-noise ratios. The graph shows interference and noise level on the discovered channels. It looks like there is quite a bit of interference on channels 36, 60, and 100, and that I should probably use channels 44 and 153. You can toggle pages on the graph to show the number of APs using the same channels. And in this case, there is some overlap in channels 36 and 44, and I should investigate this further to determine if I should change channels on some of these APs to reduce the chances of co-channel interference. cnMaestro X includes support for the use of RESTful APIs to further enhance the capabilities and effectiveness of the management system. cnMaestro X provides a RESTful API interface so that your third-party app can interact with the management system to post, retrieve, remove, and view data. cnMaestro X also provides webhooks. Webhooks provide real-time streaming for alarms using a push notification model. They provide a bridge between cnMaestro X and third-party applications such as Slack, Twilio, Datadog, and many, many more. In this example, I have created a webhook into Slack to receive real-time notifications from cnMaestro X. Okay, this concludes this video providing an overview of cnMaestro X and its key features. Thank you for your time and have a great day.